Hello, this is Brian Pangburn, and this is How to Do Crew Safely. In this presentation, we're going to talk about the basic controls, different techniques, and our standard operating procedures to keep us safe while we do crew. Okay, we're going to start off with some of the terminology that we use in crew. First off, there's two different types of docks that we do. We do center docks, which is what this picture here represents, where you basically put the center cell of your canopy onto the body of the person you're docking on. And when we do this, normally they call it a stack. The other type of dock we do is a wing dock, sometimes referred to as an offset dock, where basically we're putting the corner of our canopy onto the body of the person we're docking on. And we do that to make these diamonds. And you notice most of our big formations are diamonds. We found out that the diamonds are basically the strongest type of formation that we can build with the most amount of people. When we assign where we're going to dock on a formation, we usually say we're going to be in a certain row. The rows are actually V's. So this first one here shows if we were assigned to row 2, we would be in the first four-way. We'd be number 1, 2, 3, or 4, or actually 2, 3, or 4, and we would complete that four-way diamond. If we're on row 3, we would complete the 9-way diamond. And then it shows if it was row 4, 5, 6, etc. 6 would complete the 36-way diamond. And you can see row 7 just peeled off. Normally we don't starburst a diamond bigger than 36. So row 7 is peeling off, getting ready for the final starburst of the 36. When we exit the aircraft, we try to put 2 to 3 seconds between each jumper going out the door. You don't hang outside the airplane, you leave from inside the aircraft, leaving poised. We try to have this smooth, continuous flow out the door. Our pull delay, super critical, needs to be the same as the previous person or longer. We'll talk more about that here in a second. Normally the row 2s will leave with a 1 to 2 second delay. And then after that, whatever row you're in, if you're in row 3, you do a 3-second delay. You're in row 4, you do a 4-second delay. And we open using our rear risers, and we steer our canopy while it's opening to avoid any collisions. We'll talk more about that in a second. Once I open, get myself comfortable, then I'm going to find the formation. I don't want to turn back to the formation. I know it's back there somewhere. But I want to look to see, is it high, is it low? And I really want to start working that vertical component as soon as possible before I start heading back to the formation or while I'm heading back to that formation. And then if I'm further out in the aircraft, maybe I'm row 4, I'm going to sit there and I'm going to wait for my time. I don't need to go back and have this swarm of bees all trying to be around the hive at the same time. It just adds to confusion. So I may wait for my opportunity to come back and get into the echelon before I come back to the formation. So we have our aircraft coming along, everybody getting out 2 to 3 seconds. And then if somebody ever has an off-heading opening, normally the lines will be compressed a little bit because of the lines being twisted, and normally that person will go underneath on that 180 or whatever direction that person's going on their off-heading. So in theory, they should go underneath somebody with a full open canopy. And here's our plane again. We see the row 3s exiting the aircraft, 3-second delay, and then row 4s exiting the aircraft with a 4-second delay, and that'll put them slightly lower. And the reason we do that is as the formation builds, it tends to sink a little bit on an open canopy. And so that just puts everybody on about the right level where you don't have to sit there and do a bunch of sachets to work your level down to the formation. And that's what we found works best. We use the term echelon to describe where we stage, where we hold while we're waiting before we need to dock to the formation. So that way everybody's in this orderly area where everybody knows it would be slightly in front, slightly in high of where I intend to go next. It may be to another staging area. It may be directly to the formation, straight to the dock, but it would be somewhere in front and then high. So we use this photograph because it's got a pretty decent example of an echelon. If you look at the right side of the photograph, you can see a pretty orderly echelon where each canopy is slightly in front, slightly higher than the canopy. And then over on the left side, not so good example. It's got more of the beehive effect. Not as orderly. It's hard to predict where everybody is, where they're going to go. So this picture shows the canopies traveling all the same direction. In this case, it'd be going up on the photograph. The pilot is behind, lower than all the other jumpers. So canopy number 2 will be the first one to dock on the pilot. And he's going to sachet away from the formation or away from the pilot. We always go outside away. So if I'm on the right side of the formation, I go out to the right, and then I come back to dock heading left towards the formation. We always approach from the side. We don't want to get behind, especially low and behind. Never want to. And notice how when number 2 went out, he didn't interfere with number 4. Number 4 is out there. He's higher. He's out in front. Everybody has their own airspace. Number 3 has their own airspace. Everybody can do that. And number 3 can work their way back to the formation. Number 4 can go back where number 2 was until it's his turn. And then he can go away and then back from the side to the formation. We also have what we call the glass wall. The glass wall just simply means that if we're on the right side of the formation, we're never going to cross over the center to the opposite side. So we respect our side so we don't have any collisions. So we want to respect the glass wall rule, but when is it okay to cross that glass wall? So when I have an off-heading opening, I want to try to get back onto heading, but if I find myself to the right or to the left of this glass wall, I want to, as soon as possible, get back to the proper side of the formation. If I can do it before I get back to the formation, it's always best. Maybe I'm number 2, number 3. Maybe I don't have the opportunity to cross in front. Well, then we need to cross behind the formation, and we need to remember we need to yield to all other jumpers because we're out of position. And so we need to keep our head on a swivel, make sure that we're not interfering with any other jumpers, knowing that we're the out of position person. And then if you're on the center line of the formation, center line is number 4, number 9, number 16, 25, anybody that points out one of these diamonds, then it's okay to be on that glass wall. We just don't want to be going from the left to the right, to the left, to the right of that glass wall. Also, when we're in echelon, we never want to be directly in front of the formation or try to be directly in front of anybody else that we may be able to burble with our body or our canopy. Conversely, if we're flying our canopy, we'd want to try to avoid being directly behind somebody and a little bit high so we get into their burble. So avoid the burbles. Don't be low and in front of the formation. So let's continue with our echelon. So we had our 4 jumpers out, and now we're going to put our row 3 jumpers out, jumpers 5, 6, 7, 8, and 9 that would form that 9-way diamond. They would all come into echelon, all slightly in front of and slightly higher than the people that they're following. And so we stay into that echelon. So if I'm in row 4, where would I go? Well, I don't want to keep making this echelon huge and just extend out. So I'm just going to stay right on that center line, right when I get out of the aircraft. And I'm going to just keep working my vertical. And I'm going to stay in there till at least it's a 4-way. I have a nice stable target to come back to. There's no rush to get back to the formation. We don't need a big, long echelon. Echelon is just a staging area. I don't need to get to that staging area until it's my time. So I'm just going to stay up in front, watch the formation start to build. Once we're about a 4-way, then I'm going to start making my way back to my echelon position. So let's talk about how we can manipulate our canopy. Up to now, you've probably very familiar with your brakes. You've had to learn how to use your brakes to turn and to flare and all that. So we don't need to talk much about that. But we also have our front risers. You may or may not have used your front risers, but you're going to need to use your front risers doing crew. So we'll talk more about when and how to do that in a little bit. And then also the rear risers. Hopefully you will never need to use your rear risers. Normally you only need our rear risers if we get low and behind. And we have one more input that we can use to manipulate our canopy. Can you guess what that is? That's right, it's your body. Our body should always be the primary tool that we use. Before we start a turn, we should be leaning into the harness to help that. Before any input, the body is super, super important. We can use the body to go faster, the body to go slower, and we should really be focusing on using our body to keep that canopy as flat as possible over the top of our head. So which controls do I use when? So this picture here shows the formation or the person that you're going to be docking on in the center of the grid here, and it breaks it up into 4 quadrants. The one thing I really want you to memorize, the only thing you need to memorize out of this whole grid is if you're in front of the formation, you're going to use toggles. If you're in the back of the formation, you're going to do risers. So if that's all you remember out of this, if that's all you memorize, the rest of it should become a little bit more intuitive. So if we're high and in front, we would use our toggles, and we could sachet back to the formation. If we're low and in front of the formation, again, we would use our toggles or our brakes, and we would just slowly back up into that formation. And let's not forget about that body. Anytime we're out in front of the formation, if we just have a little bit of gap to close right there, all we need to do is make our body get big. We can grab that air and we can slow down a good full mile an hour and back right up into our slot if we need that. If we're high and behind, we would grab onto those front risers and pull those front risers down, and we can head down to the formation or the slot we're trying to get to. And then finally, if we're low and behind, we would use the rear risers. More importantly, we need to use our body. Get that body small. Pick up those legs. Put your feet behind your ears if you can. Make your body as small as possible. The smaller we make our body, the less drag, the faster we go. Anytime we're low and behind, we got to get on those rear risers. Not too much rear risers. Make our body small and slowly head up there. That's the worst quadrant to be in. So if you can avoid being low and behind, avoid at all costs. Another term you're going to hear are runbacks. Runbacks are how we simulate an aircraft exit. So we can go ahead and we can build a formation, break it apart, and then practice getting back to the formation. And the runback is how we get back to the formation. So we're practicing on getting back to echelon or how we would get right straight back to our slot. So we've got our formation flying to the left of the screen here, and then they, in this case, starburst. Once they starburst, the pilot is going to run back or head back about 7 seconds. Everybody else needs to stay flying as close to that center line as possible to simulate out of the airplane. Out of the airplane, we'd all be in a straight line. So we all want to simulate being in that straight line. All right. And then once the pilot turns around, then number 2 is going to take a right-hand 90-degree turn and head out about the width of a football field, whether it's a U.S. football field or a soccer field, doesn't matter. They're about the same. Or you can just say, I'm going to go out about 5 seconds. A good solid 5 seconds, you're going to head off of that center line. Once we've headed that 5 seconds or a football field off that center line, we're going to take another 90-degree turn and start heading back to the formation, staying parallel. We don't want to start inching in towards. We want that distance. That distance is going to allow us to be precise. And once we get to a 45-degree angle, we're going to start that turn. Nice and easy. If we went out 5 seconds, it's going to take at least 5 seconds to get back into that formation. So with that gap, that distance, we can make it real precise. And then number 3, 2 to 3 seconds after number 2 goes, number 3 is going to come back. 2 to 3 seconds later, number 4 is going to come back. every 2 to 3 seconds, just like out of the airplane, you're going to have somebody coming back to get into that echelon. So what we're trying to accomplish here is we're trying to simulate out of the airplane. We're going to try to stay as close to the center line as possible before we start coming back. We don't want to spread it out. Every 2 to 3 seconds, the next person goes back. Number 2 goes, then 2 to 3 seconds later, number 3 goes, 2 to 3 seconds later, number 4 goes. We want to get back into echelon or straight to the dock if it's available, but if not, we want to be in echelon in some position of power. We want to be slightly high, slightly in front of where we need to be so we can always come in with power into that formation. Sachets. We have 2 types of sachets. We have a sachet that if we want to back up to the formation, we can back up, and we call that a horizontal sachet where we don't lose any altitude. Or we got a sachet where we want to vertically lose altitude, and we'd roll the canopy out, roll the canopy coming back. We could combine the two. We could, if we were high and in front, we could roll the canopy, let it go out, and then roll the canopy and let it come back in. So let's talk about these a little more. So first, let's look at this horizontal sachet. A horizontal sachet is if we want to sachet back to the formation horizontally. I don't want to lose any altitude across the ground there. And all I want to do is come back to the formation but maintain. And so how I want to do that is I want to try to keep my canopy as flat as possible. I'm going to be doing a flat turn. So I may be in half breaks, doing a braking turn out. And I'm going to go out trying to maintain. I'm looking over my shoulder as I go out. Looking over your shoulder is super, super important. So I know when I can turn back. And I want to go out till I'm about on a 45-degree angle or half the distance. So if I was 10 feet in front of the formation, I would go out until I'm 5 feet, and then I'd start on my way back. And then I'm going to keep my altitude with my brakes, trying to come in and dock on that shoulder. Again, I'm aiming for the shoulder. I want to be able to have whoever I'm docking on grab the line. And here's a video example of a horizontal sachet. You can see I'm looking over my shoulder, adding just a little bit more outside brake to start that outside. Then I switch, adding just a little bit of extra inside brake, but I'm trying to keep that canopy flat above my head, aiming for the shoulder. And I'll replay that video again so you can watch how I'm just keeping that canopy really flat above my head, always watching over my shoulder so I know exactly where I'm at all times, but see how nice and flat I come. I didn't lose an inch, and docking again right on that shoulder. The next sachet is the vertical sachet. A vertical sachet is exactly what it sounds like. We're trying to lose that vertical, but we don't want to back up as much. So how we do that, or how we accomplish that, is to roll our canopy. So first thing we could do is use our right toggle. In this case, we're always going to go away from the formation. Since we're on the right side of the formation, we use our right steering toggle, go out, roll that canopy until we're about half the distance down, and then we'd use the inside toggle, or in this case the left toggle, and we'd come back to the formation using that, and then we would finish off all that extra speed that we had from all that vertical descent. We'd use the outside toggle. So in this case it'd be the right toggle again to stop all that. One of the biggest mistakes people make is not putting their hands up all the way between. So if I use my outside brake, then I need to put my hands both up before I use the inside brake to sachet on the second half of that. And again, what's our target? Our target is always the shoulder. We never want to touch fabric. That's our goal. Never touching fabric. It's getting our foot in the line, or maybe our hand in the line on the way to getting that foot into the line. And here's a video example of a vertical sachet. So you can see I'm well above, and then I'm going to take my left toggle, bury the left toggle, and then right back with the right toggle coming in. And then you saw how I slowed down with that outside brake, slowed down and parked right on that shoulder. Here's that vertical again. Again, watch how I roll that canopy to the left, roll it to the right, And then I slow down all that energy with the outside toggle and dock nice and soft right on the shoulder, using that outside brake to get rid of all that extra energy. So we just showed you examples of the horizontal sachet and the vertical sachet. And then as we talked about earlier, we can combine the two. We can roll our canopy to lose a little altitude, let it turn out, go out half the distance back to the formation, and then we can roll that canopy back towards the formation, or if we just want to do it getting back to where we want to be in the echelon, same thing. The next tool we have is what we call cross control. Cross control is when we grab one front riser and the opposite brake toggle. So if I grabbed my left front riser, I would grab my right brake toggle, and I pull them down kind of symmetrically. And what you're going to do is, some people call it warp. We warp the canopy, and so we just make it so it's not a flat, efficient canopy. Cross control is a great tool to park your canopy or slow down your canopy. Great tool. It is the absolute worst tool if you want to get from point A to point B. If you need to go sideways, vertical, whatever you want to do, if it's more than a few inches, don't use cross control. Use some other technique, but cross control is the worst one. It's only for parking or slowing your canopy. So here we have a video of some good and bad examples of using cross control. So our first one here is on the right side. The pink canopy is using cross control to park his canopy. Great application, great time, good job on the right side pink canopy. Now on the right side, we've got a red, white, and blue canopy. He's either parking his canopy too high. He should be 3 canopy heights lower. We don't know why he's doing it, but that is the wrong application to be using cross control. And now we got the pink canopy again on the right side, using cross control to park. Again, he doesn't have any more energy. He's not going to put energy in there. And then whoops, there's that red, white, and blue canopy again. Now, the reason why we brought this up is you can see how he got really close to the video guy. Guys, the video guy has like blinders on. He's trying to keep the formation in sight. He's not looking in his peripheral vision. Please, please, please stay away from the video person. Again, you shouldn't be behind the formation anyway, but don't get near the video person. He's not looking for you, and it would be a shame to have a wrap with the video person of no fault of his own. And here we got that red, white, and blue canopy, again, doing cross control. He's 3 canopy heights above his slot where he's supposed to be. Now he's doing all these crazy sachets, scaring everybody away. He should have had his altitude already fixed before he even came back to the formation. So again, just really great examples of poor technique coming from this guy in the red, white, and blue canopy. Thank you for that. Now this red, white, and blue canopy is set in the perfect set position. Now let's watch him as he goes nice and slow, just converging. Look, he's not using any inputs, just converging with his slot on there. Nice wing dock for that red, white, and blue canopy. Thank you for that great example. Okay, so how do we make the perfect dock? The perfect dock is achieved by never touching fabric. I want you to let that sink in. We should never have to touch fabric if we have a perfect dock. We should be aiming for the shoulder. The foot or hand should be able to get that line underneath there. It just makes it so much easier to get that foot in there. The perfect dock transfers no energy into that formation. We shouldn't be carrying a lot of speed. We should bleed off all that speed before we try to dock on there. The perfect dock is achieved by using the proper technique and not speed. So if we want to dock quickly after the previous person, we time it to do that. The perfect dock has 0 wrap potential, And the perfect dock will have all canopies parallel to each other. So we're flying the same direction. The canopies have no roll difference. We're all flying parallel to each other. That's the perfect dock. When we're flying relative to other canopies, or we're coming into dock to do crew with other canopies, as long as we all fly the exact same direction with our canopies parallel to each other on level, you will never wrap. So if you don't want to get in a wrap, think about it. Keep flying your canopy the exact same direction on whoever you're docking with or next to, and avoid any roll of the canopy, avoid any angle difference. It's the roll or the angle difference that will cause a wrap. So as long as we're flying parallel to each other, flying the same direction, we can bounce off of each other, off the lines, off the bodies, we'll never wrap. It's these angle differences. If I have any angle coming in, then I can go around. If I have any angle rolling, my canopy is going to want to turn around. So as long as I can keep flying the same direction, I can come in and dock. As long as I hold each canopy parallel to each other, we're never going to wrap. So here we have a four-way diamond, and we've got number 5 and number 6 coming into dock. Number 5 is what we call a wing, because it'll only have a grip on one side and not both sides. And then we have his lockup coming up, and a lockup locks up that wing. So as he starts to travel up, you can see how he's aiming for the shoulder on there. And our goal is to dock without touching any canopy, preferably when we're learning without any control. So I'm just kind of merging with the formation, and we want to stop any energy before it's taken. The goal is to stop 6 inches outside the shoulder and make that guy reach for your grip. We use the outside brake to slow that energy, but it doesn't give us lift if we only use the one brake. If we dock properly, high enough, then we should be able to just put our foot in there or grab the line. Again, we don't want to grab fabric. The closer we get to the formation, the less inputs we should be using. We should do all of our major adjustments on the way back to the formation or while we're out in echelon, and then the closer we get to the formation, we do less and less and less magnitude of adjustments. All right, so we'll watch that same video again here. We've got the wing coming in to dock, and then he puts some outside brake to slow down that energy, aiming for the shoulder. And then we've got our lockup following behind him. We try to lock up 5 to 6 seconds behind that wing so he doesn't sit out there unlocked and have a chance to go around. We want to set it nice and soft, or better yet, park 6 inches away from that shoulder. Make him reach. We want this to be smooth. If we can dock with minimal control inputs, or again, park 6 inches from that shoulder, then we put little or no energy into that formation, and it keeps everybody safe. Here are some docking tips to keep you from wrapping, hopefully. Beware of other canopies. Just because you're in the proper echelon position on the proper approach doesn't mean somebody else isn't. Beware. They might have fallen off. Somebody dropped a grip or something. So just always keep your head on a swivel looking for other canopies. Approach with your canopy as flat and level as possible. Again, if we fly level, parallel, it's impossible to wrap. Aim for the shoulder or even up at the slider. Again, our goal is to never touch fabric. Our goal is to get our foot into the line, not to grab a canopy. So if we can aim for the shoulder to slider area, then it's easier for that person that's catching to get their hand in there. If you're a lockup, and always dock on the inside grip. We never dock on an unlocked wing. That would really upset the balance of the formation, and that could end up in a wrap as well. And if you're calling in and that person's not looking at you, call the catcher's name 3 times. Hey, Brian, hey, Brian, hey, Brian, here I come. There may be times when we need to plug a slot. If we're capable or the proper wing loading, we definitely want to do it. But if we see a wing out there and it's been a while with no lockup in sight, go lock them up. Don't leave them hanging out there. For the people catching, if I'm catching somebody who's coming in and docking, we need to make sure we hand up and out to the outmost flyer. Remember, when they're coming in, it may be hinged a little bit. They may be a little behind on the opposite side, so we may need to hand forward, up, and over to hand that grip out so that wing can grab it. Always double check your grips. On that second 100 way we did, we had 100 people all docked in there, but we had one wrong grip, so it was an invalid world record. So always double check your grips. Yo, grip, grip, grip. When you come in, if you can see if they have a proper grip on your lines. If they don't have it, keep yelling, grip, 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 yell their names, let them know. And then sometimes when we're on the outside of a formation and we have bigger canopies coming in or maybe doing specialty dives, we may end up having to take a full sail grip. So we may grab the second line in. It wouldn't be a record or anything, but we may do it for safety reasons. Another force we need to talk about are the wingtip vortices. All wings have wingtip vortices that come off of them. Another reason never to get behind on the formation. There's a lot of evil lurking back there. Wingtip vortices are one of them. So we always want to approach from the outside in that clean air. Don't come from behind. Try to keep your leading edge even with the others. So this photo shows NASA had put some smoke next to a runway and had this crop dust plane come in, and so they could demonstrate how powerful that these wingtip vortices can be. And this photo demonstrates how big the vortices get. The further back, just like in the previous smoke photo we saw on the aircraft, you can see even from our canopies here, off that very bottom canopy, we've got the wingtip vortices coming up and disturbing the flag, and you can see how they start small up towards the front right off the canopy, and then it just gets bigger and bigger and bigger as it rolls back onto that American flag. And here's a swooper swooping the pond late at night. We've got the fog coming in, and you can just see the wingtip vortices coming off this swooper's canopy as he swoops through the night. And here's a video example of a jumper that's coming in from behind and low, and here as he tries to dock, oh, there he goes. That wingtip vortice just threw his canopy down into the guy below. So don't come from low and behind, and all kinds of evil back there. Here's some tips for docking and flying the wing. Remember, we want to try to dock as soft as possible, not putting any energy into that formation, and we want to set it soft. So if we dock high, we don't need to slam it down onto their foot. We always want to try to keep our hands in our brakes and then immediately have our outside hand on the front riser. We only need to pull the front riser if it's needed. Again, our goal is just to keep our canopy nice and flat. If we do need any front riser, we just need just enough to keep our canopy nice and level with the other canopies, nice and flat. Remember, we always fly our canopy. Let that lock-up canopy slide up and down on your legs so they know they're light or they know they're heavy. Fly your canopy. Your canopy is your responsibility. And fly your canopy while you're taking grips. Don't forget, your primary responsibility is your canopy. So when you're waiting for a grip, just don't ignore your own canopy. So make sure you're scanning back and forth, making sure that your canopy is still nice and flat and it's not getting too floaty or too heavy on the person that you're docked on. If we're an unlocked wing, we want to try to keep our canopy from going forward at all. Remember, you can use your body. Get your body big. We want to try to do as much drag as possible on there. Once we get 45 degrees out in front of that formation, you're going to come around. So we don't even want to get close to that 45 degrees. If I'm 30 degrees sticking out, I need to do something about it. We can use that outside toggle whip and just immediately slam it as much as possible to bring that wing back. I'd rather be floaty than to go forward. If my canopy's going up, I'd rather have it floaty like that. As long as our canopies are parallel, we're not going to wrap. But we need to try to stay level and even with others in a row. So here it shows if I float up and I look over and we're not eye to eye with the person next to me, maybe I need to add a little front riser. Or conversely, here's the opposite showing maybe I'm pulling too much. If I'm looking over at the guy's belly button or belt, then maybe I just have a little bit too much inside or front riser, and I just need to keep my canopy level with the other ones. I may need outside front riser, inside brake if I'm row 4 larger, but that's more for advanced people. That's parked out there, kind of like in a cross control. And then I also can come in and do a cross control approach and park next to it. But again, that's for experienced people. I just want you to be aware that some people may be doing that. It's probably better to wait until you have a little bit more experience. It's not the best tool, and it takes a little while to get used to. So right now, think about the basics, and then later on we can work on these fun things that opportunities like cross control. So once we're inside the formation and we've got both of our canopies and everything's flying good, we really need to focus on arching and looking up. Here, the very first example we have here, look at the space that this guy put. He's got his legs spread as far apart as he can get so those canopies next to him can get full flight. He's arching his body, trying to move as fast through the air. The faster this formation flies, the safer it is. And then conversely, look at this other guy. He's got the canopies really close behind his back, but why would he do that? Look at how much higher those canopies are going up on his leg. And so basically, he's pushing the canopies behind his back because they've got extra float, and he's trying to give them a little bit more drag so they don't have so much float on him. And so you can move the canopies apart if you want them to fly fast. You can push the canopies behind your back if you want them to fly slow. So these are little tricks that we can do to help keep the formation flying safe. Also, while we're inside the formation, the lockup still needs to fly your canopy. Your canopy is your responsibility. Make sure you're always maintaining your canopy nice and level, nice neutral on their foot. You need to try to maintain that zero tension so it's not too heavy, not floating up too much. You should be arching, looking up, spreading your legs, letting that wind go over the canopies that you're holding on to. If it does get light, does get heavy, make sure you communicate those tensions. Yell them up. Get heavy, get heavy, get light, get light. Again, always double check your grips. If we're going for a record, we want to make sure everybody has the right line, and it's good to do it in every formation just for the practice. And then you can pinch off a cell if that canopy is too floaty, kind of like what we saw the guy in the previous one where he was pushing behind his back. He could also pinch off a cell if it's really, really floaty and we're trying to keep those canopies down. Last point on inside the formation, do not hard point a canopy unless you want that canopy's energy. So what we mean by hard pointing is if somebody comes in with a lot of energy, up energy, sideways energy, if you want to take that energy, then you can go ahead and grab that canopy. But what we don't want is a lot of extra energy going through that formation. And so don't hard point somebody's canopy unless you really want that energy. So as a catcher, when would we want to let go of a grip? So this shows a view from the overhead. Anytime an unlocked canopy comes in, it normally wants to outdrive the formation that we're in. So normally that canopy will have this like 5, maybe up to 15 degree angle if it's a brand new canopy on there. No worries. This is perfectly normal. So just anticipate it might go out just a little bit in front, but that's perfectly normal. We do not want to let that go. Now, if that canopy starts drifting a little bit more forward, or maybe they came in with a little bit of energy, when they get up to 30, 35 degree angle, this is probably when I would want to let it go. We don't want to go any further than that. Bad things are going to happen. And what we found, if this gets to 45.1 degrees, it's too late. You just wrapped yourself because you didn't let them go. So if they come in and this thing gets more than a 30 degree angle, especially when it starts getting close to that 45 degree, just let them go and let them fly out in front. It's a lot safer than having them go around and wrapping you. Once we've built the formation, whether it's a 2-way, 4-way, 100-way. We have 2 ways that we can get everybody back off of that formation. The most popular, the one that we like to use the most, is called a starburst, where from the center of the formation, wherever that geometric center is of the formation, we're just going to, everybody releases exactly at once. So we'll have a countdown: 5, 4, 3, 2, 1, release. Everybody releases at the same time, and everybody heads away from that center. The other way we can do it is we break it down. Somebody might call a break it down, break it down. Maybe there's a problem inside that we can't see. Maybe somebody has a broken line for whatever reason. A break it down, we do exactly the opposite of the build. So if we built a 4-way, we would let number 4 off, then we'd let number 3 off, and then number 2 off. But the opposite of how we build it, we break it down. And here's another picture of a starburst. Again, it's got a circle where the geometric center of that formation is. So if we were directly above that, we'd go straight up. If we're directly below that, straight down. Maybe we go to the right, maybe we go up and right, down to the right. Maybe we use front risers to go down and to the right. Maybe we use our brakes to go up. Whatever we need to do to get away from that center is what we do. Once we're bigger than a 36-way, we found starbursts don't work so well, so we will peel rows off. So this shows the row 7 wings and all the lockups leading, and so you can see everybody's using the same amount. And pretty much what we try to do is try to put our center cell on the body of the person that we're following out, and that just keeps it nice and orderly, so we don't have some people going out too fast, some too slow, to where we can have another wrap potential, because we are getting closer to the ground. One issue that we do run into with the crew canopies is crew canopies are not engineered for good openings, and they're not engineered for good landings. They're engineered to stay pressurized so we can grab onto lines. They can reinflate quicker. They're trimmed steeper, larger front openings to grab all that air. So because they're not engineered to land nice and smooth like a free fall canopy is, we need to learn how to do that. So NASA gives us all these really nice formulas here so we don't have to think about it. And basically what they're talking about here is the aerodynamic force is related to the square of the velocity. What does that mean? Well, that means if we double the velocity or double the airspeed going over the top of that wing, we're going to quadruple the lift. And so if we double the speed, it quadruples the amount of lift. So the faster we go, the more lift we're going to get. However, if we also double the velocity, we also quadruple the drag. So both the lift and the drag get quadrupled. So how do we counteract that drag? Well, we have to make our body small. And as small as possible when we come in. How do we increase the speed? Well, the best, safest way when we're learning is to just pull on the front risers as hard as we can pull them from, 150, 200 feet. Just pull on them, release the front risers slowly, and start your flare. And it should just be a nice continuous movement where we release and flare. You don't change your flare height. We just need just a little bit more speed, a little bit more wind going over the top of that canopy to give us a little bit more lift, and we'll have a softer landing. So here again, they give us the different coefficients of drag. All these objects have the same thickness except for the airfoil. And you can see if we're a flat plate or we're our body with our legs just dangling below us, we are a flat plate. The coefficient of drag is 1.28. If we can make it a prism, a little bit for less behind us, 1.14. So just a little bit better, but not as good. But if we can make ourselves into a ball, it says the coefficient of drag 0.07 to 0.5. That's our goal, is to pick up our feet, try to make our body as small as possible when we come in for landing, and that will reduce our drag. Here's a chart with some different glide ratios. We got a modern sailplane, 45 to 70 to 1 on the glide ratio, very, very efficient. A 767 that ran out of fuel has a 12 to 1 glide ratio. Good to know if you're flying commercial. A PD-190, back when they used to publish the stats on a wing loading about 1.0, had a 2.6 to 1 glide ratio. And look at that, it almost matches what a wingsuit glide ratio is, 2.5. What I put on here is the northern flying squirrel has a 1.98 glide ratio. Why would I put the northern flying squirrel? Because it's the same as a lightning. The lightning has about a 2 to 1 glide ratio. So what we want to do is get that glide ratio up to a 2.5, 2.6, and we can land it just like a PD-190. So that's why we want to pull on those front risers, get the speed, make our body small, reduce our drag so we can have a better landing. One other consideration we need when we're landing our canopies is density altitude. We don't have density altitude charts for our canopies, but here's one for a Cessna 172. It directly relates to landing a canopy, just like these takeoff and landing distances matter on these charts. So if we're at sea level, it takes this Cessna 720 feet to take off on the runway. If it gets a little hotter, we have to add 24% ground roll to take off. So we went from 32 degrees up to 86 degrees. Now, even worse is if we're higher up. And so here we go up to Denver, about 5,000 elevation. Now our ground roll is up to 1,150 feet, or we increased 60%. Now we do that same thing up in Denver on a hot day when it's 86 degrees, and now we double the amount of runway we need to take off. So same thing with the canopies. The higher we are in altitude, the less efficient they are. The hotter, the less efficient they are. So we just need to keep that in fact. Maybe we had a good landing when it was in the winter time and now we can't do it in the summer. That's why the density altitude is so much higher. And engineering, big ways. When we engineer, we pay attention to a lot of different things, wing loadings, everything. Another thing we want the base or the top of the formation to fly fast. And so what we normally do is all the people along the center line, the people up top, we want them wearing tight clothes. We want brand new canopies. We want the center and the top of the formation to fly fast. On the outside, we want the canopies to go slow. So we'll have people with baggy clothing on there, old ragged out canopies. We'll have people wearing 3X that only weigh 100 pounds. We're trying to add as much drag on the outside of that formation to slow the outside of the formation to keep this thing healthy. We also adjust the breakoff altitude by the size of the formation. So when we were doing the 100 ways, our breakoff altitude was 4,000 feet. Or if we have clouds, maybe we'll break it off just before we get to that cloud layer. Even though we're not going to go through the cloud, usually right around that cloud level, it gets bumpy, so we'll break off at that altitude.